Here we're going to start how to measure Q. So let me delete this here. Okay, and why is this important? Well, remember we know the total energy, oops, total energy, no, don't do that. Okay, let me just do a new one. New. Okay, so again, the total energy, delta U, equals to Q plus W. Okay? Now, we need it where this is heat and this is work. Okay, so now let's measure how do we get Q? Okay? Here's the formula for Q, and let's think about this. Q is MC delta T. MCAT is how I kind of like to remember it. So Q is MCAT. So when we're looking at Q, Q is heat. Keep that in mind. So when you think of heat, you should think of a temperature change, right? So that's what delta T is. Delta just change in, so we're looking at a change in temperature. So anytime we heat something, there will be a change in temperature. Okay? So delta T is just your temperature final minus your temperature initial. Okay? So this is just your change in temperature. Okay, that's all that is. Mass, M. Mass in grams. Okay, so let's think about this. So we know there's going to be a change in temperature, but it's going to also depend on how much of something we have, okay? If we have 10,000 grams of something versus 1 gram, do you see that it's going to take a lot more energy to heat up something that's 10,000 grams versus 1 gram, okay? So we need the mass in the equation because we need to know how much we have because that's going to depend on how much energy it's going to take. Okay, so that's why mass is in the equation. C is called a specific energy. Let me show you this. Specific heat or specific energy. And this is a, sometimes it's called heat capacity. Basically, this is the energy required, right here, to heat up 1 gram of substance. Okay, so C we're going to call this specific energy because I think it sounds better. Or we'll call it specific heat energy. Oops. Energy, if I can spell. Okay, this is basically the energy. I'm going to abbreviate this N, R, G. This just means energy required to heat up 1 gram of a specific substance. So basically, how much energy does it take to heat up something? So let's think about this. Let's go to this chart here. The amount of energy it's going to take to heat up lead versus silver will be different because they're different compounds. Ethanol versus water, again, it's going to take a different amount of energy, so you have a specific energy, okay? And this is a constant. You have to look it up. Usually they'll give it to you in the problem. Every once in a while they'll say to look it up, okay? So we have Q. We're going to look at how much mass we have, the energy it takes to heat up that mass, and the change in temperature that you get, okay? And that is Q. So let's look at a actual problem. So File, New. Let's go to pink. So again, let's write down our formula. Q equals to mc delta T. Now let's look at our problem here. Okay, suppose you find a copper penny in the snow. How much heat is absorbed by the penny as it warms from the temperature of the snow, which is -8, to the temperature of your body, 37. So it's starting at -8 and it's going to 37, okay? So my temperature initially is -8 degrees Celsius, and the final temperature is 37 degrees Celsius. Let me give you the units of C. This is joules divided by gram degrees Celsius. So the temperature actually needs to be in degrees Celsius because C is in degrees Celsius, okay, for them to cancel. Let's look what else we have. It says, assume the penny is pure copper. Okay, so this is a copper penny and has a mass of 3.1. So I know mass equals 3.1 grams. I need to look up C. C is a constant. It doesn't give it to you in the problem, so I have to look it up. Look at this chart. And it says copper is 0.385. Okay? So C for copper is 0.385 joules per gram degrees Celsius. Okay? Now we have everything. We have our M, we have our C, and we can calculate delta T. Okay, so let's actually calculate delta T first. So delta T equals to temperature final minus temperature initial. Okay, so let's put this in. Our final temperature is 37. Oops, 37 minus a -8, right? So this will end up being 37 plus 8. Let's see. So we do 37 plus 8, which is 45. So delta T is 45 degrees Celsius. Alright, so now let's plug everything in. We have Q. Our mass is 3.1. Our C is 3.385. And our delta T is 45. And let's look at our units, okay? 3.1, this is grams. This is in joules, grams, Celsius, and this is Celsius, okay? So Celsius, Celsius cancel out. Grams and grams cancel out, and that leaves us with joules. So our final answer, Q, will be in joules, which is energy. Remember, Q is heat energy. So we have 3.1 multiplied by 0.385 multiplied by 45, and I get, let's say, 53.6 joules. Okay, so that is how much energy in the form of heat in this reaction. So it says how much heat is absorbed. Okay, so let's think about that. If energy is absorbed, that means we gain energy, right? We absorb it. So what sign should it have? Positive, right? Because we're absorbing energy. We're not releasing energy. Remember, we want things given to us, so we want to absorb it. So that's positive. And look what we got here. We have a positive number, so that's good. So I'm just showing you that it all comes together. So that's how you calculate Q. It's just mc delta T. So we have a change in temperature because we're looking at heat energy, the amount of energy it takes to heat, to that temperature, and the mass that we have. And so the next podcast we'll go over W. Because again, let's remember, Q or delta U is Q plus W. Okay? So if we want, so far we know delta U equals to Q. Q is mc delta T plus W. This is Q. Okay? So now let's go and define what W is. How do we calculate that?